Kafka is a durable shared event log. Applications write events into named topics, and other applications read those same events later, at their own pace. Producers append without naming their readers, and consumers pull on their own schedule, and that decoupling is why Kafka exists. An event is just a fact that something happened, and a log is the timeline of those facts. New records append at the end, old ones stay as written, and a read only moves your bookmark. The record itself stays on the log. Retention policy decides how long that history lives, and each consumer tracks its own position on the same timeline. People often call Kafka a queue, and a classic queue usually hands a message to one worker and then the message is gone. A durable log keeps the record so many readers can process it, later and with different jobs. You can still use Kafka in a queue-like way inside one consumer group, but the deeper model is the shared log. Independent pace is the point. One consumer can sit near the end of the log while another lags behind and catches up later. Kafka doesn't force every reader into one SLA. Each advances its own bookmark on the same durable history, and that gap between log end and bookmark is lag. Later lessons deepen offsets and groups, but the picture starts here. Compare two designs. With point-to-point HTTP, the producer calls every dependent service in the request path, so failures cascade and every new dependent means editing the producer again. With a log, the producer finishes when the append succeeds, readers catch up when they're ready, and a new team can subscribe later without changing the writer, which is why Kafka shows up even when a queue already exists in the stack. Kafka shines when independent readers need durable fan-out and replay. If one worker should take a job and finish it, a classic queue often fits better, and for tight request response between two services, HTTP still wins. Match the tool to the job when you need fan-out, replay, and many readers reach for Kafka. Here's the smallest local proof: create a topic, produce a message from one process, then start a consumer with from beginning, and you'll read what was written earlier, even if the producer is already gone. The log stores facts so another process can read them later. Now the concrete example. Your order API places an order, and email needs a confirmation, analytics needs dashboards, fraud needs a risk check, and accounting needs revenue. Instead of order API calling each service over HTTP, it appends order created to a topic once, and email, analytics, and fraud each read that same fact at their own pace, so a new team can join later without opening the producer again. If you remember one sentence, remember this: Kafka is a durable shared event log. Producers append facts, and many consumers read those facts independently, including later, including after a crash, and including by a team that didn't exist when the event was written. Next Kafka lesson drops soon. Subscribe so you don't miss it.